Comets are among the most mysterious travelers in our solar system. But what if I told you they also have a voice? Thanks to groundbreaking space missions, we've captured the eerie songs of these celestial wanderers. Join us as we explore the fascinating story behind these otherworldly sounds. Comets, often called the cosmic snowballs of our solar system, are fascinating celestial bodies made up of ice, dust, and rock. They're remnants from the solar system's formation, holding clues to its early history. Picture a comet as a frozen time capsule, preserving the primordial ingredients of planets, moons, and even life itself. Most comets originate in two distant regions: the Oort cloud, a spherical shell of icy objects at the edge of the solar system, and the Kuiper belt, a donut-shaped region beyond Neptune. Occasionally, gravitational nudges send them hurtling toward the sun, creating their iconic glowing tails. Beyond their beauty, comets have played a vital role in shaping life as we know it. Scientists believe they delivered water and essential organic compounds to early Earth, potentially jump-starting life billions of years ago. But these icy wanderers are not as silent as they seem. Hidden within their interactions with solar winds lies a haunting melody, a cosmic symphony that spacecraft have begun to unravel. What do these songs reveal? Let's explore. How do we hear the voice of a comet? The answer lies in a fascinating process called sonification. While space is a vacuum and sound as we know it cannot travel there, spacecraft like Rosetta carry instruments capable of detecting invisible signals, such as magnetic field oscillations and plasma waves, around comets. These oscillations are essentially rhythmic fluctuations caused by charged particles interacting with the comet's environment. For instance, the magnetic field around Comet 67P, Churyumov-Gerasimenko, exhibited pulses at an incredibly low frequency of 40 to 50 millihertz, far below the range of human hearing. To make these signals audible, scientists convert them into frequencies we can perceive by amplifying and speeding them up. Think of it as turning invisible vibrations into music, much like a radio converts electromagnetic waves into sound. This process reveals a whole new dimension of the cosmos, one we can not only see but also hear. Imagine this: as solar winds collide with the gas and dust surrounding a comet, a unique melody emerges. Visualize the spacecraft's instruments detecting these subtle movements, transforming them into dynamic sound waves, like a cosmic DJ creating a soundtrack of the stars. By sonifying these signals, researchers have unlocked a new way of experiencing space. And as we'll soon discover, Comet 67P's song is unlike anything you've ever heard. But why do comets create these melodies? Let's dive deeper. In 2004, the European Space Agency launched the Rosetta mission with an ambitious goal: to study Comet 67P, Churyumov-Gerasimenko, up close and for the first time land a probe on its surface. After a 10-year journey, Rosetta arrived at the comet in 2014, and the Philae lander made its historic touchdown, providing unprecedented insights into the composition and behavior of comets. But the mission unveiled more than just physical data. As Rosetta approached 67P, its instruments detected a strange phenomenon: oscillations in the comet's magnetic field at a frequency too low for human ears to hear. Scientists enhanced the signal, amplifying it by a factor of 10,000, and what emerged was astonishing: a haunting, otherworldly melody, now famously known as the Song of Comet 67P. Imagine hearing this ethereal sound while visualizing the icy, rugged surface of 67P, surrounded by a glowing halo of gas and dust. The mystery deepens. Why does the comet sing? Scientists believe the answer lies in its coma, the atmosphere of gas and dust that forms as sunlight heats the icy nucleus. Charged particles from the solar wind interact with the ions in the coma, creating oscillations that are captured by magnetometers. Yet even today, questions remain. Are these oscillations unique to 67P, or do all comets have their own melodies waiting to be discovered? As we move forward, let's explore how other comets compare to 67P's cosmic symphony. While Comet 67P's haunting melody captivated the world, it's not the only comet to have sung. In 1986, the Giotto spacecraft flew by Halley's Comet, capturing data that was later transformed into sound. Unlike the smooth oscillations of 67P, Halley's Comet produced a chaotic, crackling signature, a reflection of the dynamic and turbulent environment around its nucleus. The sound is harsher and more erratic, evoking the image of an ancient traveler battling solar winds as it blazes through the inner solar system. These recordings show that each comet may have its own unique voice, shaped by its size, composition, and interaction with solar radiation. Hypothetically, future missions could record sounds from other comets, potentially creating a library of cosmic symphonies. Imagine the deep bass hum of a giant Oort cloud comet, or the shrill tones of a smaller, fast-moving object near the Sun. Listening to these sounds side by side reveals the diversity of the cosmos. From the eerie harmony of 67P to Halley's fiery crackle, each comet tells its story in a way that's as unique as its journey. But what exactly causes these celestial tunes? Let's explore the science behind these enigmatic sounds. The melodies of comets arise from a fascinating interplay of cosmic forces. At the heart of this symphony is the coma, a halo of gas and dust that forms around a comet as it approaches the Sun. When sunlight warms the comet's icy nucleus, volatile materials like water and carbon dioxide vaporize, creating this glowing envelope. As the solar wind, a stream of charged particles from the Sun, collides with the ions in the coma, it generates oscillations in the magnetic field surrounding the comet. These rhythmic fluctuations, though invisible and inaudible in their raw form, are the source of the comet's song. Imagine the process. A comet streaking through space, its icy surface releasing jets of gas and dust. Solar wind particles bombard this material, creating ripples in the magnetic field, much like wind blowing across a field of tall grass. Instruments like magnetometers on board spacecraft detect these subtle oscillations, which scientists transform into audible sound. This interplay is unique to each comet, depending on its composition, speed, and distance from the Sun, which raises a tantalizing question. If we could sonify every comet, would each one have its own melody? Perhaps some would hum a steady bass line, while others might emit chaotic, high-pitched chirps. The diversity of these voices could hold clues to the nature of comets themselves. Listening to these cosmic symphonies offers not just an auditory experience, but also a deeper understanding of these celestial travelers. Let's reflect on what these sounds mean for our exploration of the cosmos. The songs of comets offer more than just an eerie soundtrack. They're valuable tools for understanding these celestial wanderers. By analyzing the patterns and frequencies of these recordings, scientists can study a comet's composition, the behavior of its coma, and its interaction with solar winds. Future missions could take this even further, capturing sounds from a variety of comets to create a rich auditory map of the solar system. Each new recording would add to our knowledge, helping us uncover the secrets of these icy relics. But beyond the science, these sounds spark a sense of wonder. Each comet song is a reminder of the hidden symphonies in our universe waiting to be discovered. They challenge us to listen closely, to seek out the melodies of the cosmos, and to explore the mysteries that lie beyond the stars. Let's wrap up this journey with some final thoughts. From the haunting melodies of Comet 67P to the crackling chaos of Halley's Comet, these sounds remind us that space, though vast and silent, holds hidden music. Each celestial body, shaped by its unique journey, has a story to tell, not in words, but in frequencies and vibrations waiting to be uncovered. What might asteroids sound like if we could hear them, or distant planets with their swirling atmospheres and magnetic fields? The possibilities are as endless as the universe itself. These cosmic symphonies challenge us to think beyond what we see and imagine the sounds that fill the void of space. If you've enjoyed this exploration into the voices of comets, make sure to like this video, share it with fellow space enthusiasts, and subscribe to our channel for more journeys into the unknown. And don't stop here. Check out our other videos. Until next time, keep listening to the cosmos.